Welcome to this explainer. Today we are going on an absolute whirlwind, fast-forward tour of our blue planet's incredibly chaotic, violent, and honestly fascinating history. Over the past few billion years, Earth has literally been pummeled by asteroids, crashed into other planets, frozen solid multiple times, and ruled by some seriously crazy life forms. Frankly, it's a sheer wonder that our homeworld is even still here at all. Okay, let's dive into this. When you really think about it, Earth is the ultimate protagonist, right? It has survived a literal cosmic gauntlet, overcoming disaster after disaster just to foster life. And by looking at the staggering scale of what our planet has endured, we can truly appreciate just how delicate and highly volatile the ground beneath our very feet actually is. So, to make sense of these massive billion-year timescales, here's our quick roadmap. We're going to cover 1. A violent cosmic birth. 2. The first water world. 3. Supercontinents and complex life. 4. From the Great Dying to the dinosaurs. 5. The rise of humanity. And 6. The big question. Our next mass extinction? All right, Section 1. A violent cosmic birth. Let's rewind the clock. Roughly 4.5 billion years ago, early Earth emerged from the swirling disk of interstellar gas and dust. But this young world was nothing like the one we know today. It was highly volcanic, constantly spewing massive amounts of hydrogen sulfide, methane, and carbon dioxide to form a completely toxic atmosphere. Oh, and it was also being relentlessly bombarded by large asteroids and comets. But the real climax of this chaotic birth happened when a literal Mars-sized planet named Theia slammed right into us. This epic, incredibly violent collision threw huge chunks of matter all around Earth's orbit. Over time, gravity bound all that debris together to form our moon. Moving right along to Section 2, the first water world. Following that intensely fiery era, the planet underwent a massive transformation. About 3.8 billion years ago, Earth finally cooled down just enough for water to condense and become liquid. A primitive ocean covered the young Earth, turning it into a literal water world. And this brilliantly illustrates a key point. Liquid H2O provided the essential ingredients for living things. Sure enough, about 3.7 billion years ago, life first appeared in the form of tiny, microscopic organisms. But it took nearly a billion years after that for life to really start altering the course of the planet, which happened when cyanobacteria evolved around 2.4 billion years ago. Just look at the dramatic before and after contrast here. It's like night and day. These tiny cyanobacteria became our planet's very first photosynthesizers. They started pumping out oxygen, which made the atmosphere so much more hospitable. But there was a catch. With all this new oxygen, Earth's atmosphere suddenly had much lower levels of carbon dioxide. This actually caused the planet to become icy cold, freezing over much of our young world in Earth's very first ice age. Section 3. Supercontinents and complex life. Beneath those early oceans, land masses began to rise and assemble. Think of it like a giant shifting puzzle. We started with Valbara, our first supercontinent, which was actually smaller than modern-day Australia. Then came the giant Rodinia, which was likely the largest supercontinent to ever cover the planet. After Rodinia broke apart, Pannotia assembled, which eventually leads us to Pangaea, about 250 million years ago, our last vast supercontinent. And it was upon these constantly shifting landmasses that life began to take entirely new, highly complex shapes. During a really specific window between 540 and 485 million years ago, Earth experienced what scientists call the Cambrian explosion. Suddenly, boom, there was this massive, rapid burst of new life. Animals evolved to have hard body parts, like shells and spines. The most famous of these were the incredibly alien-looking trilobites. And not too long after that, roughly between 420 and 350 million years ago, the very first trees arose from the soil, and animals bravely made their first transitions up onto dry land. It sounds like an absolute biological paradise, doesn't it? But did early complex life actually survive the shifting climate? That's the suspenseful part. Because the harsh reality of Earth is that progress is rarely uninterrupted. Around 440 million years ago, the climate suddenly shifted. Ocean temperatures changed drastically, and it brought about Earth's first mass extinction event, the Ordovician-Silurian extinction. A huge majority of life just vanished. Which brings us to Section 4, the Great Dying to dinosaurs. Life on the supercontinent of Pangaea brings us to a period of absolute extremes. So, the crucial point is this. During this era, immense amounts of greenhouse gases triggered accelerated global warming, causing our greatest mass extinction event ever, ominously known as the Great Dying. It wiped out an astonishing 90% of all species on Earth. Just let that sink in for a second. 90%. Nearly everything died. But as is always the case on our incredibly resilient planet, destruction paved the way for the next wave of evolution. From 240 to 230 million years ago, the very first dinosaurs appeared, and they would go on to rule the land for a staggering 150 million years. This was the legendary era of giants. We're talking massive beasts like the Argentinosaurus, literally the largest land animal ever, and of course, the iconic apex predator, the T-Rex. And during their epic reign, Pangaea began slowly breaking apart into the fragmented continents we recognize today. Now, you probably know how this chapter ends. Exactly 66 million years ago, a massive asteroid slammed into our planet, right where present-day Mexico sits. It kicked up so much dust and debris into the atmosphere that it literally blocked out the sun. This sudden, catastrophic climate change completely wiped out the dinosaurs, ending their 150 million-year run. But at the exact same time, it opened the door for the next wave of emerging animals to take over, mammals. Section 5. The Rise of Humanity. Let's fast forward through millions of years, right up to our own doorstep. Around 6 million years ago, early humans emerged, though they still walked on all fours. Let's move to and see how this builds, because the acceleration of our survival skills is just incredible. By 4 million years ago, early humans began walking upright. Soon after, around 3 million years ago, they developed the very first tools. Then came a massive game changer. 800,000 years ago, early humans discovered how to control fire. They could cook food, they could stay warm, and because of this, their brains began evolving more rapidly than ever, allowing them to interact with their environment in completely unprecedented ways. From there, the pace of societal evolution is just breakneck. Between 40,000 and 15,000 years ago, every other human species besides Homo sapiens actually went extinct. About 10,000 years ago, wandering nomads finally put down roots as the earliest farmers. Then jumping way forward to just 250 years ago, the Industrial Revolution triggered sweeping technological changes, rapidly transforming rural, farm-based societies into the highly industrialized urban global force that we are today.
Finally, Section 6, our next mass extinction.
That incredible rapid acceleration brings our chronological journey directly to the modern day. By 1804, our human population reached 1 billion. By 1927, we hit 2 billion. But since the 1960s, that number has just exploded faster and faster. Today, to put it into perspective, the global human population stands at over 8 billion people. Now, this explosive growth puts an unprecedented amount of pressure on our planet. Today, we are seeing rising worldwide temperatures, rising global sea levels, and a rapidly declining rate of biodiversity. Remember the greenhouse gases we talked about during the Great Dying? Well, these current shifts carry that same profound historical weight. These are the modern challenges documented right now in our planet's ongoing, deeply complex story. Which leaves us with this final, highly provocative question. If things don't change, are we on the verge of another mass extinction event? Earth is a masterclass in survival, built upon relentless cycles of destruction and rebirth. We've survived asteroids, ice ages, and planetary collisions. But given the rising temperatures and declining biodiversity we are seeing right now, could we be standing on the brink once again? It's a fascinating and sobering thought to walk away with today. Thank you so much for joining me on this explainer, and remember to keep questioning the incredible world around you.